All right, let's finish up section 6.1. The only thing we have left to do is kind of solve a little bit more complicated problems. And I also kind of want to summarize what we went over in the last video because it was kind of long. So I'm going to try to keep this one a little bit shorter. Okay. All right. So we looked at the functions and their inverses. So on this first page, you can see I have it all listed, but I want to modify these a little bit and just kind of refresh what we went over in the last video. So remember, we wanted to restrict the original function so that it would pass the horizontal line test, right? We want to include all potential y output values, and we do not want them to repeat. And we also want to try to include 0 where we can. So this is our sine function. I'm going to write these bigger because this is just hard to see. This was y equals sine x. And remember, we restricted it from negative pi over 2 to pi over 2 because we were able to cover all y values from negative 1 up to 1 using just those values, right? So then whenever we invert those, then on our y-axis, so this is the inverted version, okay? This is y is equal to sine negative 1x, okay? So all I did was take the picture and invert it. So the numbers look kind of wonky here because I just took this picture and flipped and rotated it, okay? So now this one is going to go from negative pi over 2 to pi over 2. So negative pi over 2 to pi over 2, right? That used to be my x's. That's now my y's. And then my y's used to go from negative 1 to 1. And notice now my x's go from negative 1 to 1. So that's this little piece right here, okay? Now remember, when we're inverting these, we don't want repeating values. So it's not necessary to use the rest of the function. So we don't need all this up here. We don't need all this down here, right? We just need that little piece that covers everything we need. Okay, so when we look at sine, we can see that our domain is from negative 1 to 1, and our range is from negative pi over 2 up to pi over 2. So I'm going to go ahead and just flip over this page, and we have kind of like a little short reference here that I want to fill in as we go along. So our domain is from negative 1 to 1. And our range, right, if we look back over here, is going to be from negative pi over 2 up to pi over 2. Negative pi over 2 to pi over 2. Okay, so if I think it, well, I'll fill that in a minute. We'll fill that in a minute, okay? All right, so now let's look at cosine. If we look at cosine, remember, again, we're wanting to restrict it so that we get all possible y values, but no repeats. So we started with our normal cosine starting point, and we just went down to pi, right? Because if we start at 0 and go over to pi, that gives us every y value between negative 1 and 1. Okay, so when we invert that, instead of our x's going from 0 to pi, now our y's are going to go from 0 to pi, right? And our y's, instead of going from, instead of our y's going from negative 1 up to 1, now our x's go from negative 1 to 1, right? So we end up with just this little piece right here. Again, we don't need all this, and we don't need all this. Okay, so this is just really quickly going over what we did in the last video where we flipped the paper over. Okay, so let's go ahead and fill in for our cosine inverse values. So our domain is 1 to 1, or sorry, negative 1 to 1, and our range is 0 up to pi. So on the next page, we're going to fill in our domain value as negative 1 to 1, and our range value as 0 to pi. Okay, all right, now let's look at tangent. Tangent, remember, we could use the whole thing. We didn't have any reason to have to restrict it, right? We had to restrict this one, and we had to restrict this one, because if we didn't restrict it, we would have not passed the horizontal line test, right? If I draw a horizontal line across this sine curve, it's going to hit a whole bunch of points, which is why we had to restrict it to just a little piece. But this one, I could draw the horizontal line test all day, and it's not going to cause an issue, which means that I could use this whole thing, right? This is cosine x This is tangent x. So I could invert this whole thing, which gives me my tangent inverse function, or the arctangent function, right? So there's no restrictions, which means that my domain is going to be negative infinity to infinity, right? Because it's going to keep going in both directions. And then my range is going to be from asymptote up to asymptote, right? So from negative pi over 2 up to pi over 2. So let's go ahead and fill that in. So domain keeps going left and right with no bound, no restriction. And our range went from asymptote up to asymptote. Now asymptotes, they can't take on that value. So we need to use parentheses for negative pi over 2 up to pi over 2. Okay, so just filling in all this up. And we did this the other day. We found all these values whenever we did the flipped paper thing, right? We wrote all the domain and range values below the thing. So you can just copy that over, but I want to just quickly, make sure we remember how we got those values. All right, so that was sine, cosine, and tangent inverse functions. Now let's look at cosecant, secant, and cotangent. So cosecant, remember, this is one that we definitely had to restrict, right? Because it had repeating values. So we chose half of each parabola to cover from 1 up to infinity and from -1 down to -infinity. And we chose the halves that were closest to 0, right? Because we wanted to include 0. So that means on our chart, we're going to go from negative pi over 2 to pi over 2. Since that was our original domain restriction, that's now going to be our restriction on our y values here, right? So we're only going to use this one and this one, okay? The thing to remember with cosecant, though, is that the y-axis was an asymptote, right? So whenever we rotate it and flip to get the inverse, now the x-axis is an asymptote, okay? So we can see here that our x's are going to be from negative infinity up to 1, right, where this piece ends. And then it's going to pick, or sorry, -1. And then it's going to pick up again at +1 and go on out to positive infinity. And our range values are going to be everything between negative pi over 2 and pi over 2 except 0, because there's an asymptote there. Okay, so let's go ahead and write that in for, oops, I forgot to write it. Y is equal to cosecant inverse. So for cosecant inverse, we just determined that our domain is from negative infinity to -1, right? And then 1 to infinity. And then the range of our secant value, remember, was anything between negative pi over 2 and pi over 2, except for the x-axis, because that was an asymptote. So that means we can go from negative pi over 2, which is included, over to the x-axis, which is 0, right, because that's an asymptote, and then 0 up to pi over 2. Okay. All right, we got 2 more. Let's look at secant and cotangent. So this was our, oops, and I forgot to write it, cosecant. So y is equal to secant x, right? So on this one, we also had to restrict it, right? Otherwise, it would not pass the horizontal line test. So we want to choose the one closest to 0, so that would be this piece, right? And then we can't use that side because that gives us the same y values, so we needed this side right here, okay? So that means we're going from 0 to pi, right, on our x-axis. So when we invert it, we're going to be going from 0 to pi on our y-axis, right? And then for our y's, notice we're starting up here at 1 and going up, and then from -1 we're going down. So that's what's going to be happening on our x-axis, right? From -1 we're going to be going back in that direction, and from +1 we're going to be going in this direction. And then we do want to make sure that we take that asymptote, right? Let's take that asymptote. All right. So notice on these ones that we're restricting, we don't need the rest of this function, right? So here we don't need all this stuff under the x-axis. So we only need this piece in order to be able to graph secant inverse of x. Okay, so our domain is going to be from negative infinity to infinity, but we have to take out this piece between -1 and 1. And then our range is going to go from 0 up to pi, but we have to take out pi over 2, right? Because we have an asymptote there. So let's go ahead and fill that in on the next page. So on the next page for secant, our domain was negative infinity to -1 and 1 to infinity, right? And then our range was from 0 up to pi, but we have to take out the asymptote that was at pi over 2. So when we take it out, make sure you use parentheses up to pi, which is included. Okay? All right, let's look at our last one. This is definitely a page that I would flag or star or dog-ear the page or whatever, so that you have this to look back at when you take when you have your homework or when you're prepping for your exam, things like that, because this is something that it will make a difference, making sure you know what the possible outcomes or range values are for these functions. Okay, let's look at the last one, and then we'll show you how we're going to use them. Okay, all right. Oh, and I forgot to mark out this. We don't need all this. We don't need that. We don't need that. Okay, so let's look at cotangent. So y equals cotangent x. Cotangent, remember, we cover all the y values, right? Which here just continue on and on and on. So there's no restriction for cotangent, just like there was no restriction for tangent. But we do want to make sure that we include our asymptotes so that we know if our domain and range has parentheses or brackets. So when we invert this to get cotangent inverse function, okay, notice here on our original function we went from 0 out to pi on our x-axis. So now on our y-axis we're going to go from 0 up to pi. And then our y values on the original were unbounded. So when we invert it, now our x's are unbounded. Okay, so let's go ahead and fill that in on our chart, and then we'll look at how we're going to use that to help us. Okay, so for cotangent, whoops, inverse, now our domain is unbounded, so negative infinity to infinity, and our range is going to be from asymptote to asymptote, which was 0 to pi, and because they're asymptotes, we want to make sure that we use parentheses, right? Okay, so now what I want to look at is I just want to look at this output. Okay, so if we know that our output has to lie between negative pi over 2 to pi over 2, I want to think about what quadrants that is. Okay, so thinking about quadrants, I'm going to just write it up here. Okay, this is 0, this is pi over 2, this is pi, and instead of writing this as 3 pi over 2, I'm going to think of it going in the negative direction. So if I went in the negative direction, this would be negative pi over 2, right? So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, so if I look at sine inverse, my sine inverse function has to be between negative pi over 2 and pi over 2. So here's negative pi over 2 to pi over 2, right? So that would be these two quadrants. So that means either quadrant 1 or quadrant 4. I'm going to go ahead and just list that here. This is a good way to check when you're going through your homework to make sure that you use the right signs, that you got the right answer, that it's in the right quadrant, is to check back with this chart. Okay. When we look at cosine, cosine has to be from 0 to pi. So if I think about that in terms of quadrants, 0 to pi would be these top two, right? So quadrant 1 or quadrant 2. The next one is negative pi over 2 to pi over 2, and we've already done that one here, right? The only difference here is that the actual negative pi over 2 and pi over 2 values aren't included, but that still means it's going to fall in quadrant 1 or 4, right? From negative pi over 2 to pi over 2. And then same thing here, negative pi over 2 to pi over 2. That's also going to be here. The only thing is it can't equal 0. But that's still going to cover quadrant 1, quadrant 4. Same thing. Next one, we have 0 to pi, right? We're taking out pi over 2, but this is still 0 to pi, right? We're just saying it can't equal this. But it's anything over here or anything over here, which is going to be quadrant 1 or 2. Okay? And then our last one, 0 to pi, this is going to be quadrant 1 or quadrant 2. Okay? So that's going to help us when we start solving some of these expressions. And we want to be able to solve it without a calculator, okay? So when I'm grading your homework or grading your exam, if you have a problem that looks like this and you just have an answer, you will receive 0 credit for it, okay? I want to see that you worked it out and you showed me how you solved for it using a reference triangle, okay? If you don't have a reference triangle, you're not getting credit for it, okay? All right, so let's look at this. This says we're evaluating the cosine of sine inverse of 1/3, okay? Now, we can't evaluate cosine of another trig function, right? We need to have an angle. We need to be able to figure out the cosine of an angle. So I'm going to kind of just do a little substitution. I'm going to say, let's just call this whole mess, let's just call that theta, because then it's like we're looking for cosine of theta, right? Which makes more sense. So I'm just going to say, let's let theta equal the sine inverse of 1/3, okay? And now this is something I can simplify, right? I can get rid of that sine inverse if I take sine of both sides. So if I take sine of this side, I'll get sine theta. If I take sine of this side, my sine and my sine inverse are going to cancel, right? And so I'll just be left with sine theta is equal to 1/3, okay? So since we're talking about sine, remember, or sine inverse, is either going to be in quadrant 1 or quadrant 2, okay? And here, because our sine value is positive, we know that that has to be in quadrant 1. Since this is a positive, that means we're in quadrant 1, okay? So I'm going to go ahead and just figure out what that reference triangle looks like. If I'm in quadrant 1 and I know that my angle's sine value is 1/3, remember sine is opposite over hypotenuse, right? So if I draw my reference triangle, I know that the opposite of this theta angle is going to be 1, and I know the hypotenuse is going to be 3, right? So I know that much about theta, but remember, I really want to figure out what cosine theta is, right? So I'm just going to rewrite this. Now that I'm calling whatever's inside here theta, I'm really just trying to figure out what cosine theta is, right? Which is adjacent over hypotenuse. So here's what we know about theta. We know that its opposite value is 1, and we know its hypotenuse is 3. So we know that the bottom of this is going to be 3, but we need to know the adjacent side in order to be able to finish out solving for the cosine, right? So I'm just going to use the Pythagorean theorem, right? We're missing this x value, this adjacent side. So I'm just going to use the good old x squared plus our y squared, which is 1 squared, equals our hypotenuse squared, so 3 squared. So this means that x squared plus 1 equals 9. If I subtract my 1, that means x squared equals 8. And then I take the square root of it, right? So I have x is equal to plus or minus the square root of 8. And because it's in quadrant 1, we know that it's positive. So now we know that that adjacent side is the square root of 8. So now we can calculate the cosine of theta, right? So all of this stuff written in pink, this was just to figure out what my reference triangle looks like so that I could find all the given side lengths. And now that I know what angle we're talking about, now I can figure out what the cosine of that angle is. Okay, and here we just figured out that that's the square root of 8 over 3. Okay, so that is my solution. And I don't think that it makes you simplify this radical, but if it does, you know, 8 is 4 times 2, so you could simplify the square root of 4. So I'm going to go ahead and put down here cosine theta is equal to the square root of 8 over 3, or if they make you simplify that radical, this is also equal to 2 square roots of 2 over 3. Okay. On an exam, I'm fine with you stopping here, but my math lab might make you simplify it out a little bit further. Okay. All right, let's look at another one. Same idea. This says we want to figure out the secant value of the angle that satisfies this. Okay, remember this is a measure of an angle. So I'm going to go ahead and say this we're just going to call theta, right? So what I'm really trying to find in the long run is I want to know what's the secant value of theta. Okay, so I need to figure out everything that I know about theta. So we're saying that theta is equal to cotangent inverse of negative 15 over 8. Okay, so to get rid of a cotangent inverse, what we need to do is take cotangent of both sides. Okay, so that gives me cotangent theta is equal to cotangent evaluated at cotangent inverse negative 15/8. And that way my cotangent and cotangent inverse cancel. So that gives me cotangent theta is negative 15/8. Okay. And I'm not used to doing a reference triangle with cotangent. So you could change it into tangent, right, by just doing the reciprocal, or you can make your reference triangle with cotangent. It doesn't matter. You'll get the correct answer either way. I'm going to go ahead and flip it just because I'm used to dealing with tangent. So tangent theta would equal negative 8/15. Okay, and we know that tangent is opposite over adjacent, right? So we have to think about this in terms of what quadrant it's in. Okay, tangent right now is negative. So if we think about where tangent is negative, that means the ratio of sine to cosine is negative, which means I don't have two positives and I don't have two negatives. So this is only going to happen if this is negative. A negative tangent is only going to happen, right? Let me write a thing. So over here, my x's and y's are both positive. Over here, my x's and y's are both negative. So I know that those are not going to work, right? So a negative tangent happens in quadrant 2, and a negative tangent happens in quadrant 3, right? But we're starting with cotangent. So let's really quickly reference our chart that's up here above. Cotangent inverse has to fall in quadrant 1 or quadrant 2. So I'm going to go ahead and look down here. So quadrant 1 or quadrant 2, so it's going to have to be this one. Okay, so it's going to be quadrant 2. So I'm going to go ahead and say that this has to be in quadrant 2. So I'm going to go ahead and draw my reference triangle in quadrant 2. I know that this is now my theta angle. Okay. All right. So let's label it. So opposite over adjacent. So this opposite side should be a positive number, right? Because it's above the x-axis. So my 8 is going to be positive, and my adjacent should be a negative x value. So the negative is going to go with the 15. Okay. And now I just need to figure out what this radius length is, or this hypotenuse length, right? So I'm going to go ahead and do my quadratic formula, which says that x squared, so negative 15 squared, plus my y squared, so 8 squared, is equal to my radius squared, or my hypotenuse squared, however you want to write it. Okay, so negative 15 squared gives me a positive 225 plus 8 squared, which is 64, equals r squared. 225 plus 64 gives me 289. And then when I take the square root of that, I get plus or minus the square root of 89. And we know that this, because it's the hypotenuse, it should end up positive, right? And the square root of 289 is 17. So I know my hypotenuse length is 17. Okay, so I know everything I need to know about this theta. So now what I'm looking to solve is the secant of theta. So remember, secant theta, secant is equal to, let's see, secant is related to cosine, right? Cosine is adjacent over hypotenuse. So if I flip that, that would be hypotenuse over adjacent. So I'm going to take my hypotenuse over my adjacent side, which means that secant is equal to hypotenuse, which is 17, over my adjacent, which is negative 15. Okay, or you can put this negative out front, right? So we're just going to leave it like that. Okay. Does that kind of make sense? A little bit. Hopefully not the worst thing we've ever seen. All right. I have 4 more examples, and then y'all can do this homework. Hip, hip. Hooray. All right. So I'm going to skip this first one for a second. I'm going to do B first. Not necessarily because this is any, well, I don't know. Do I need to do that? I don't know that that makes it any harder or easier. Nah, I'll do A first. Why not? Jump right in, right? Okay, so what this is saying is that we want to find the sine value of this angle, right? And the way that we find this angle is we figure out what these pieces tell us. Now, unlike the other ones we did, the other ones from the other page, notice we just had one thing in here. We just had one thing on the inside, right? But on this one, we have 2 things, right? We have this whole mess, and we have this whole mess, right? So I'm going to call them 2 different things. I'm going to call this one A, and I'm going to call this one B. Now you can call them X and Y, you can call them alpha and beta, you can call them theta and epsilon, I don't really care. But we're just going to label them 2 different things. And then I'm going to work this out the same way I did the last one. So I want to find everything I know about this angle A. So what I'm saying is that A is equal to arctangent of 4/3. Now, if I want to get rid of that arc, right, or that tangent inverse, I need to take tangent of both sides. So when I take tangent of the left-hand side, I'll get tangent A is equal to, now when I take tangent of this side, it's going to cancel, and I'm just going to be left with 4/3. Okay, so this should be enough to allow me to draw a reference triangle, right? Okay, tangent is positive, so this is going to fall into quadrant 1, right? So let's go ahead and draw our little reference triangle. We know that tangent is opposite over adjacent. So opposite this tangent A angle is going to be a 4, and adjacent is going to be a 3. So I need to figure out what this other length is, right? So again, I'm just going to use the quadratic formula, which says that my x squared plus my y squared equals my hypotenuse squared, right? So I'm going to do 3 squared plus 4 squared equals my radius squared, or my hypotenuse squared. 3 squared gives me 9. 4 squared gives me 16. So that means that 25 is equal to my radius squared. Now, I can do the square root of 25 in my head, right? That's going to give me plus or minus 5. But since this represents the hypotenuse, we know it has to be a positive 5. Okay, so this length is 5. All right, so now I know everything I need to know about this A angle, just like we did on the last problem, right? Now what I want to do is the same exact thing with my B angle, okay? Now I'm not going to worry about this negative because that just tells me I'm subtracting these two angles. So I'm going to go ahead and say we're letting B equal the arc cosine of 12/13. So just like we did over here, I want to get rid of that arc or that inverse. And the way that we get rid of an inverse is we apply the original function, so cosine of both sides. So if I do cosine on the left-hand side, I'll have cosine B. If I do cosine on this side, my cosine and my arc cosine will cancel, and I'll just have 12/13. Okay, and that should give me enough information that I can go ahead and write out my reference triangle. Okay, cosine here is positive, which means that this is going to fall into my quadrant 1, right? First quadrant. And we know, so this is B, and we know that cosine is adjacent over hypotenuse. Okay, so adjacent to my B angle is 12. Hypotenuse is 13, and we just need to figure out what this x length is. Okay, so again, I'm going to use a quadratic formula to figure out what that missing side length is. So if I do my x squared, 12 squared, plus my y squared, which we don't know, that should equal 13 squared. So 12 squared is 144, plus y squared equals 169. If I subtract my 144, that's going to give me y squared is equal to 25. And then again, I take the square root, which means y equals plus or minus 5. And here, because we can see that this y value is above the x-axis, then we know it's going to be a positive 5. So this length is 5. Okay? All right, so I know everything I need to know about my A. I know everything I need to know about my B. So really, I could rewrite this problem as sine of A minus B, right? Now, where does that look familiar? Do you remember the difference and some identities of sine, cosine, and tangent? So I'm going to bring back my handy dandy formula sheet, and remember those are all my double angles. Remember these? Cab sab for cosine and ABBA so cool for our sines. So what we have here is we have a sine of two angles being subtracted, right? So if I look back at my sine of two angles being subtracted, I do the sine of the first angle times the cosine of the second minus the sine of the second times the cosine of the first. So I'm going to go ahead, let me see if I can get all this on here at once. There we go. So I'm going to go ahead and just fill this in. Okay, so this is equal to, and I'm going to write it down here because I don't think I can make it fit. Sine A times cosine B minus sine B cosine A. Okay, so now that we have that, now we should be able to simplify this, right? Because we know everything we need to know about A, everything we need to know about B. So really we just need to fill in these values so that we can get an answer. Okay? All right, so let's look at sine A. Sine of A would be opposite over hypotenuse. So opposite is 4, hypotenuse is 5. So that's 4/5. Cosine B, so here's my B function. Cosine is, oh, we already have it written here. Cosine B is 12/13. Okay, and then we need sine B. So looking at our B function, still sine is opposite over hypotenuse. So opposite is 5 over our hypotenuse, which is 13. And then we're going to go ahead and fill in with cosine A. Cosine A here would be adjacent, which is 3, over hypotenuse, which is 5. Okay, and once we have everything filled in, then we can go ahead and just simplify. So if I multiply these out, that's going to give me 48 over 65 minus 15 over 65. And then I combine those, which gives me 33 over 65. So same thing we did on the last problems in terms of renaming these just an angle and figuring out everything we need to know about it. The only difference here was once we rename these A and B, then we actually could use one of our subtraction identities of sine functions to simplify. Okay, let's do the same thing on this next one. So this one says we're looking for sine of this function. So the first thing I'm going to do is I'm going to call this function something else, right? So let's go ahead and call this function, I'm just going to use theta, okay? So we're looking for, ooh, and I don't want to include the 2. I don't want to include the 2. I just want it to be that. In fact, let me rewrite that. I didn't mean to do the 2. Because I don't want to have to solve with that 2 in there, right? But also, if I just call this piece theta, then what I have here is I have sine of 2 theta. And that's a double angle identity that I can actually simplify, right? So let's figure out everything we need to know about theta so that we can then simplify this, okay? So if I let theta equal the arc cotangent of -5. All right, so to get rid of this arc cotangent, we need to take cotangent of both sides, right? So cotangent of the left side is going to give me cotangent theta. When I take cotangent of the right-hand side, it's going to cancel with the arc cotangent, and I'll just be left with -5. Okay, now remember when we're looking at cotangent or arc cotangent, let me bring my chart back, it has to be in quadrant 1 or quadrant 2. Okay, so I have to think about where cotangent is going to be negative. Is cotangent going to be negative in quadrant 1 or quadrant 2? Well, cotangent is related to tangent, right? So if I want to think about where tangent is positive or negative, it's a ratio of sine and cosine. So here sine and cosine are both positive, so that's going to give me a positive cotangent tangent, right? Here I have a positive sine, but a negative cosine, so that's going to be negative. And then I don't even have to worry about the other quadrants because arc cotangent is only quadrant 1 or quadrant 2. So the fact that we have a negative cotangent value tells me that this is going to be in quadrant 2. Okay, so I'm going to go ahead and draw my reference triangle in quadrant 2. And remember, cotangent is the inverse of tangent. If tangent is opposite over adjacent, then cotangent would be adjacent over opposite, right? So again, I don't have a fraction here, but I can always put it over 1 to create a fraction. So that means my adjacent side is -5 and my opposite side is 1. So I just need to figure out this hypotenuse length right here, okay? So I'm going to use a quadratic formula. So we're going to say that our x squared, so -5 squared, plus our y, which is 1 squared, is equal to our hypotenuse or our radius squared. So -5 squared is 25 plus 1 squared is 1 equals r squared. So that gives me 26 to be r squared. And so I take the square root. So square root of 26 equals r. And I'm just going to go ahead and take the positive because I know I'm solving for the hypotenuse, and the hypotenuse is always positive. So that gives me the square root of 26 as that length. So now that I know everything I need to know about theta, I should be able to figure out sine of 2 theta. Now sine of 2 theta, that was one of my double angle identities. Oh, let me just set my paper. Here it is. So if I look up my double angle identities, let me scoot this up. You can see here that sine of a double angle is equal to 2 times sine of that angle times cosine of that angle. So here it's written as 2a. We have a theta. So I'm going to go ahead and just rewrite this as 2 times sine theta cosine theta. That's our double angle identity, right? So now that we have that identity, Now all we have to do is fill in these values. So it's going to be 2 times whatever that is times whatever that is, right? We just need to fill in what those values are. Sine of this theta angle is opposite over hypotenuse. So opposite is 1 over the hypotenuse, which is square root of 26. And then we need to do our cosine value. Our cosine value is adjacent, which is -5, over hypotenuse, which is square root of 26. Okay, and now that we have it all filled in, all we have to do is multiply it all together. So if I multiply straight across here, excuse me, that's going to give me -10 over square root of 26 times square root of 26 is square root of 26 squared, right? Which is then just 26. And then we can go ahead and reduce that. That reduces to -5 over 13. And that's my final answer. Okay. All right. So hopefully we're kind of okay on the figuring out everything we need to know about the angle so that we can then simplify the outer piece of it. I want to look at kind of going in a different direction. So same idea, notice we have cotangent of some angle, but unlike the other ones we were doing, the value is not given, okay? So if the specific value isn't given, they're just giving you like a u, we're just gonna assume u is positive, and we're gonna come up with an answer in terms of u, okay? So we wanna do the same thing here. I'm going to go ahead, excuse me, and we're going to call this inner function something other than what it is. So I'm going to go ahead and just call this theta, okay? So we're looking for cotangent, you know, at the end of the day, we're looking for cotangent theta. So let's figure out everything we know about theta, okay? So we're saying that theta is equal to secant inverse u, okay? Now, to get rid of secant inverse, I can go ahead and just apply regular secant on both sides. So when I do that, that's going to give me secant theta is equal to, now when I do secant theta on the other side, or secant on the other side, my secant and my secant inverse will cancel. So this tells me that secant theta equals u, right? Now, I want to change this into something that I'm used to work. Well, I guess we'll just leave it. We'll just leave it. Never mind. Because we know what secant is, right? Secant is the inverse of cosine. Cosine is adjacent over hypotenuse. So if we invert that, that's going to be hypotenuse over adjacent, right? So I'm going to go ahead and just write this as u over 1. Okay, we don't know the actual number, but we can still make a reference triangle out of it. So if I make a reference triangle here, and this is my theta, right? We're saying that the hypotenuse here is going to be u, and the adjacent side is going to be 1. So we should be able to find this other length here, right? So let's go ahead and find that other length by just doing a quadratic formula. So quadratic formula, I do my x squared, so 1 squared plus my y value squared equals my hypotenuse squared, so u squared. And we're solving for this y side that we don't know. So 1 squared is just 1, and I'm going to go ahead and subtract it to the other side. So I have y squared is equal to u squared minus 1. Okay, so I simplified the 1 squared, and then I subtracted it to the other side. And now to get y by itself, because we're solving for this y length, right, I take the square root of it. So y is equal to the square root of u squared minus 1. Now I can't simplify this, because even though I see a u squared, it's stuck like glue with that -1. And this is not a perfect square factorable thing that factors into a perfect square. So I'm just going to leave it like this. Notice I didn't do plus or minus because I already know my y should be positive. It's above the x-axis. So I'm going to go ahead and just label this side as the square root of u squared minus 1. Okay, so notice I have everything I need to know about theta. It's just labeled in terms of u because u is what they let us know about it. Okay, so now that I have everything labeled, now I just need to go ahead and figure out what cotangent theta is. Okay, so cotangent theta is going to be, remember, cotangent is the inverse of tangent. Tangent is opposite over adjacent. So cotangent is going to be adjacent over opposite. So our adjacent side is 1 over the opposite side, which is the square root of u squared minus 1. Now, on an exam, I would be fine with you stopping right here. That's all I care about, is that you were able to find and label these sides and give me this function. On your homework, though, they might have you rationalize the denominator. Okay, so in this case, it's pretty easy. To rationalize the denominator, we would just multiply by that square root, u squared minus 1, u squared minus 1, on top and bottom. Okay, so we would end up with the square root of u squared minus 1 all over u squared minus 1. Okay, so my math lab might make you take that one extra step, but on an exam, I would be fine with you stopping here. Okay. All right, let me show you one more like that where we have to write it in terms of u, but where it also involves one of our double angle identities. Okay, so this looks similar to 2 times something, right? So I'd like to be able to write this as sine of, 2 times some angle. Because if I have a double angle identity, I have a formula for that, right? If I want sine of 2 theta, that's the one we used earlier, right? Sine of, oh wait, those are addition and subtraction. There it is. So sine of a double angle, right, is equal to 2 times sine of that angle cosine of that angle, right? But before we can plug in for that, we need to know everything we need to know about that angle so that we can fill in its sine and cosine values. So I'm going to go ahead and just take this little nasty piece, and we're going to call that theta, right? So let's figure out everything we need to know about theta. So theta is equal to cosine inverse u, okay? And to get rid of the cosine inverse, we're going to take cosine of both sides. So cosine of theta is just going to be cosine theta. Cosine of cosine inverse u, cosine and cosine inverse will cancel, and I'll just be left with u. Okay, so we know that cosine of theta is just u. And I'm going to write that as u over 1, because we know that cosine is adjacent over hypotenuse, and that will help me to label my triangle. Okay, so if I want to make my reference triangle, we know that the adjacent side is u, and the hypotenuse is 1. Right? What we don't know is this length. So I want to do the same thing, solve using the Pythagorean theorem. So I know that the x side, which is u squared, plus the y length, which I don't know, y squared, is equal to my hypotenuse length, which is 1 squared. Okay. So 1 squared, I can simplify that to 1. And remember, I'm solving for y squared. So I'm going to take this u squared and subtract it to the other side, minus u squared. And then to get y by itself, I take the square root. So y is equal to the square root of 1 minus u squared. Again, I cannot simplify this because even though there's a u squared, it's stuck like glue to this 1 with that subtraction sign. So this is as simplified as I can get for y. So I'm just going to label that side 1 minus u squared. Okay, so now that I know everything I need to know about this theta angle, I should be able to fill in for these values, because this just says I want to do 2 times whatever the sine is times whatever the cosine is and simplify, right? So let's find our sine value. Our sine value is opposite over hypotenuse. So we have the square root of 1 minus u squared all over 1. And then cosine theta is adjacent over hypotenuse. So u over 1. And the good thing about this is because everything's over, because everything's over 1, I can just multiply it all out and it's over 1, which really means it's just itself, right? So if I multiply the whole top, then I end up with 2 square root of 1 minus u squared times u, right? All over 1, which is just itself. And then I'm just going to rewrite it with this u up here by the 2 so I don't have to have parentheses. So 2u square root of 1 minus u squared. And that's it. Okay. All right. So that is the end of 6.1b. It was just taking the concept that we went over in 6.1a and kind of taking it up a notch. So this is a little bit of a shorter assignment. If you have questions, please let me know. There's no worksheet for this one, just the My Math Lab. But if you have questions, let me know because I'm happy to help. Otherwise, I'll see you on the next video.